Hello and welcome to the final video demonstration of Project 17 in MUN's ECE 5000 course for winter 2024. My name is Tanzim Masood, and for this project I was tasked in developing a Home Assistant and Arduino based 3 lights control system. Now this is the approach I took for my design. As you can see up on the front, we have the 3 LEDs as required. Over on the right side, we have a power input port, which powers both the LEDs as well as the Arduino microcontroller on board. Over on the left side, we have a USB-C data input port, which connects directly with the Arduino microcontroller on board in order to communicate with the serial port. And at the bottom, we have some specifications for the box, more of which will be provided with the brochure. Now, before I begin with the demonstration, I have to point out some disclaimers. I am an electrical engineering student, and this is an electrical engineering student design project. I am not an expert. I am not a professional. I am merely a hobbyist and a student looking to learn more about electrical engineering design and electronics in general. If you have any feedback, any criticism, or any questions regarding the project, please feel free to leave it in the comments down below, and I will be sure to look through them and respond where I can. Now, without further hesitation, let's move on to the demonstration. Thank you. With the ARD123 Lights, you will also receive a wall adapter to connect the device to the mains power. There's a DC barrel jack connector here, which connects directly to the power in port on the device. Then there is a 32 gigabyte USB flash drive, which contains the virtual machine and the programming for the microcontroller in case it needs to be reflashed. Then a typical USB-A to USB-C cable just to connect the Arduino microcontroller inside directly to the PC using the USB-C data in. Now that we have all of those connected, we can open up the USB drive to see that there is a .zip file located within the ARD123 Lights.zip. Opening this, we see all of the files required for the project. We have 2 folders which contain the code, an Arduino-CLI folder which contains a compiler for the code, and a VM files folder which contains the virtual machines for the program. Next, we have an executable file as well as 2 pictures that are used alongside the executable file. Now, having those extracted, we can directly start with the executable file and see that this is a simple GUI to be used with the project. To begin, first we need to click on virtual machine controls. We can read the instructions here for better view. But first, find VirtualBox application, and luckily for me, the program remembered my last location that I specified for VirtualBox. But if that's not the case, you can simply navigate over to your VirtualBox installation. Mine is in my F drive, Program Files, VirtualBox, and we can just select that folder right there. We see it says success. Within the folder, it specifically looks for the vbox manage.exe application. So if that's present in the folder, then it is most likely the correct VirtualBox installation. Over on the left, we see there are saved credentials, but since it's the first time we're running the program, there are no saved credentials and we need to add them later. So after that, we can create the virtual machine. Click on there and we can see that the command prompt opens up. We can also open up VirtualBox right here. There is nothing right now currently, but when that is complete, it creates a virtual machine from VirtualBox. Now we could either run it from VirtualBox itself or use the application to start the virtual machine. Now, while that's starting up, make sure we're connected to the wireless. I am using a mobile hotspot as that is the only Wi-Fi I have access to, which supports the project. So for that, let me just type in the uh, SSID. So that's the username, the SSID and the Wi-Fi password entered, but we still need an entry for the broker hostname. To find that, we can read the instructions and see that we need the EMP0S3 IPv4 address from the virtual machine. Hold down over there, and IPv4 address for EMP0S3 is 192.168.130.249. 192.168.130.249. We click on store credentials and refresh. So right now we have these credentials saved right here, and we can upload the program to our device. Click on upload program. Over here we see that it installs some of the dependencies for the device, and after that's done, needs administrator privileges to install some of the dependencies. But once that's done, it should start uploading, it should start compiling and uploading the code right there. There we go. And uploading. All right, uploaded. Now from here, we can directly launch the dashboard. Click on that. And we have the dashboard launched. Now that we have the power cable connected, we could open up the GUI again and re-upload the program. This is a really quick way of resetting the board in case something goes wrong or it needs to be refreshed for some reason. Maybe it disconnected or the Wi-Fi credentials or the Wi-Fi setup changed. But anyways, as you can see, the lights turned back on and the blinking sequence is there. This is a really useful way of resetting the board in case something happens, as I mentioned. Now going to the dashboard that was launched with the launch dashboard button, you can see that each LED has a control setup for itself. So there's LED 1, LED 2, and LED 3. These are simply toggle switches. Now we also have some special modes for each LED. So there's the toggle after mode, testing that on LED 1. Let's set the timer to 10 seconds and click on the activate. So as you can see, the timer starts ticking down from 10 seconds, and once it reaches 0, it toggles the LED from off to on. Now we could do it again. So in 10 more seconds, LED 1 should toggle from on to off. And there we go. Toggle until for LED 2. Let's set the timer to 8 seconds. Now what this does is it toggles the LED from off to on, in this case, for the 8 seconds that we input, and after the 8 seconds it toggles it back off. pretty simple to understand, pretty self-explanatory. Finally, we have the blink sequence being tested on LED 3. Now, what this does is, again, pretty self-explanatory. We queue up 6 seconds and the LED 3 turns on after 6 seconds, and after another 6 seconds turns back off. So in a way it blinks every 6 seconds, or it's a blinking sequence with a period of 6 times 2, 12 seconds. Now we can see that we can disconnect the USB-C cable and the lights are still working. This is because the device is an IoT device. It is already connected with a Wi-Fi connection, and it shouldn't need any USB, any wired connection other than obviously the power connection right there. So let's set that to toggle after, and toggle that off. LED2, LED1 behaves as normal, and there we go. We could re-upload the program again just to make sure that as you can see, error during upload. It cannot upload the program because there is no USB-C cable to upload it with. However, it still works fine. Now we could reset. I'm taking off the power connection and then putting it back in. Give me a moment. We can do a hard reset and we can see it still works. So there we go. That is a demonstration of the ARD123 Lights, the final demonstration. A real quick update. I forgot to mention that from the GUI, we can kill the dashboard when we need to, right there. And we can see that the dashboard turns off, and we can also start the virtual machine back on when we need, as demonstrated previously, right there. And this will turn back on normally. Now, every time it turns on, it should receive the same IP address as the broker host name input previously, though it may change if the virtual machine has not been opened in quite a while, or if it's moved to a new wireless network. So again, we can kill that and that'll turn off. Again, any feedback, critiques or comments, well, comments, yep, leave those in the comment section. And as always, thank you for watching and have a good day, night, or whatever's in between. To verify that my design met the requirements and specifications it needed to, let's open the course shell. And over here, this is project 17. So the requirements asked for a Arduino and Home Assistant OS based 3 lights on-off control system installed on a USB drive and controlled through a web page. So for my system, I have 3 lights controlled using an Arduino board and a Home Assistant virtual machine installed on a USB drive. And the virtual machine can be used to launch a dashboard, which is used to control 3 lights. So I believe that meets all the requirements and specifications, and a product brochure will be uploaded along with the final submission, which is on April 5th. Thank you.